All right, in this video, we are going to solve these rational inequalities over here. So let's start with this first question. Now, the first step of any rational inequality is to make one side zero. So I'm going to move this term to the left side, and I'm going to subtract it on the left side. The next thing we want to do is we want to make a common denominator. So I got to multiply x minus 4 on the top and bottom here, and x plus 6 on the top and bottom here. Now I have a common denominator of x minus 4 times x plus 6. The next thing you want to do is you want to expand the top and you want to combine like terms. So I'm going to FOIL out these two brackets and I'll do it a bit quick. I won't show the individual steps because you should be pretty good at expanding at this point. It's going to be x squared plus 9x plus 18. And over here, it's going to be x squared minus 5x plus 4. Never expand the denominator, always leave that the same. Now I'll distribute this negative into this bracket. So x squared minus x squared just cancels each other off. 9x minus negative is going to be positive. So 9x plus 5x is going to be 14x. And 18 minus 4 is 14. Denominator just stays the same. And now that this is fully simplified, we can tell the solutions to the top are the zeros and the solutions to the bottom are the vertical asymptotes. So let's start with the zeros in this question. Over here, I know that if I pick x as -1, basically, I'll show the steps here really quick for this first question, but I won't do it for all of them because you should be able to tell zeros instantly. And then divide by 14 on both sides. So my 0 is x equals to -1, but you should be able to tell that instantly over here. My vertical asymptotes are the solution to the denominator, which are +4 and -6. So now that I have my zeros and my vertical asymptotes, I want to put them on a number line. You can use a sign chart as well, but I find a number line to be a lot quicker. I'm going to put my vertical asymptotes and zeros on my number line. You should have put them in order from lowest to highest. And then we want to test each range to see which interval is good and which one is bad. So I'll pick -7 first. I'll do f of -7. And you want to sub it in basically this equation over here. It's the easiest one. Sub it in. So I'll do this in my calculator. And I get -84/11, which is not greater than equal to 0, which means that that interval is not good. The next interval I'll pick a value between these two. So I'll do f of -2. Which is 7/12, and 7/12 is greater than 0, so this interval here is good. I'll pick a value between these two. I'll just do +2. There's -21/8, which means that interval is bad, and then the last one I'll do is +5. which is 84 over 11. That is greater than or equal to 0, which is good. Which means in this questions, we have two good intervals, this interval here and this interval here. Now, in the question, we had a greater than equal to sign, which means we have to use square brackets for our zeros, but vertical asymptotes always use round brackets. So the zeros are inclusive because of the equal sign here, but vertical asymptotes are always non-inclusive. So -6 is a vertical asymptote. So I'm going to start with a round bracket, -6, and then it ends at -1, which is going to use a square bracket because that's a 0. Then my other interval is from +4, which is a vertical asymptote. I'm going to use a round bracket, and then till infinity, which always uses round brackets. So that is my final solution, this first question. Let's try this second question over here. Again, similar steps, just a bit of practice. Start by moving this to the other side. And then I'll make a common denominator. So I'm just going to multiply the top and bottom here by 2x plus 6. My common denominator is just 2x plus 6. Oops, I forgot to write my sign, less than 0, less than 0. I'll just expand this out on the top. I can also factor the bottom if you want. Not necessary, but I'll do it just for fun. So 2x squared plus 6x plus 10x plus 30 minus x, and then the bottom I'll just write as 2x plus 3, and that's less than 0. Combine like terms in the top, so that's 2x squared plus 15x plus 30 divided by 2x plus 3 is less than 0. Then we need to factor the top over here. So what multiplies to 60 and adds to 15? 20 and 3 doesn't work, 15 and 4 doesn't work. That's not possible. So we got to try quadratic formula. X equals -15 plus or minus root of 15 squared minus 4 times 2 times 30 divided by 2 times 2. Do the discriminant first. So 15 squared minus 4 times 2 times 30 is -15. So this is actually not possible to factor because my discriminant is negative, which means there are no zeros in this question. You cannot factor the top. So no zeros. And my vertical asymptote is just the solution to the denominator, which is x equals -3. Now, the sign is just a less than, there's no equals here. So even if we did have zeros, our final solution would just be all round brackets. But we don't even have any zeros. All we have to do is put our vertical asymptote over here. We have two intervals to test, f of -4, and I'll just test f of +4. Why not? I want to sub it in this equation over here. So again, I'll do this in my calculator. I get -1, which is less than 0. Remember, something less than 0. -1 is less than 0, so this interval is good. And then over here, I'll test +4. Could test 0 as well, but it's just easier for me to change the negative to a +4 in my calculator. I get 61 over 7, which is not less than 0. So this interval is no good, which means that my final answer is just this interval here, which is -infinity to -3. And let's go to the final question for this video over here, which is this one over here. Again, just a bit of practice. I'll start by moving this to the other side and making the other side 0. This one again has a less than equal to sign. Then I'll make a common denominator. So x times x plus 1 minus 1 times x plus 4 divided by common denominator is just x plus 4 times x plus 1 less than equal to 0. I'll just expand the top and combine like terms. X squared plus x minus 4. Denominator doesn't change, it just stays in factored form. These two cancel, so I'm just left with x squared minus 4 on the top, and if I factor that, it's x plus 2 times x minus 2. Bottom is still the same. Now this is fully factored. We can state our zeros, which are the solutions to the top. My zeros are just -2 and +2, and we can also state our vertical asymptotes, which are the solutions to the bottom, which are -4 and -1. Now we can just do our number line and test out all our intervals. -4 is the lowest, followed by -2, followed by -1, followed by +2. So 5 intervals to test in this question. Start with picking a number right there. So I'll start with f of -5. Then I'll do f of -3. Then I'll do f of something between these two, so -1.5. Then I'll do f of 0. And finally, I'll do f of 3. I'll test these 5 values for my 5 intervals. Start with -5 in my calculator. And I get 21/4, which is greater than 0, so that's no good. Pick a value between these two, and I pick -3, so let me test that really quick. Get -5/2, which is less than equal to 0, so that's a good interval. Next, I'll test -1.5. Just 7/5, so that's no good. And then f of 0 is next. This is -1, so that's good again. And then last one I will test is +3. This is 5/28, so that's no good. So we have 2 good intervals over here for this one. Remember, -2 and +2 are zeros. So for this interval, we also had an inclusive sign there. So -4 is a vertical asymptote, so round bracket, -4, -2 is a zeros, square bracket, union, and then here, -1 is a vertical asymptote, so round bracket, and +2 is a 0, so I have a square bracket, and that's my final solution for this one. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button, as it really helps this channel. Thank you for watching and have a wonderful day.